All right, advanced math. Gonna try to put a nice bow on proportional relationships today. I'm not really gonna present you with anything new, totally, so to speak here, so much as try to tie everything together in a nice package for you. Which I guess it doesn't make a lot of sense for the package and the bow to be brown. You wouldn't do that, would you? Let me make it red. There we go. That's a better gift to receive. So go ahead and make this the title of your last proportional relationships page in your notebook, and on we'll go. All right. So there are three situations where you can decide if a relationship is proportional or not. Proportional. And find your constant of proportionality and your unit rate. Those are all the big things to find in these situations. Proportional relationship, constant of proportionality, and unit rate. And we can look at verbal explanations, tables, and graphs are all the most helpful ways we have learned to find it. So this one I'm going to give you the verbal and talk you through the table and the graph. So this says, Amaya is making crafts to sell at the Maker Faire. She can make half of an item in 10 minutes. Is there a proportional relationship between time and crafts? What is her unit rate of crafts per hour? So this is the situation in words. So if I were to make a table of that, I would say, minutes is independent, so that's probably going to be my X. And the number of crafts depends on the minutes. So I usually make that my Y. Y is the dependent. So like 10 minutes, half a craft, 20 minutes, a whole craft, 30 minutes, 1.5 crafts, 40 minutes, 2 crafts, and so on and so forth. And so there's my table. And it says, is there a proportional relationship? Well, let's make the graph first. If I wanted to make the graph, I can use both at the same time. I'm just going to put these ordered pairs on this graph. So minutes is my X. Remember, X is this axis. Y is this one. So minutes, I may as well go in tens. 10, 20, 30, 40, 50. I probably should use graph paper here, but I didn't. And then number of crafts, 1, 2, 3, and so on. And so according to my table, 10 minutes, half a craft, 20 minutes, 1 craft, 30 minutes, 1.5 crafts, and so on and so forth. I could keep going, but I don't have to. And say, because my graph will show me. I can extend that out. And from there, I can find, 40 minutes, 2 crafts is on there, 50 minutes, 2.5 is on there, and I can keep going on and on forever. All right. So is there a proportional relationship between time and craft? So I can go over here, and I can find that by finding the constant of proportionality here. I can do y divided by x. That's a half divided by timeout. Almost got some. Well, I can do that. Half divided by 10 is 1/20th. Down here, 1 divided by 20 is a 20th. And so I might have, this one looks kind of difficult to divide, so I might do 2 over 40 down here, which is 1/20th. And so I can see that I keep getting this same constant of proportionality. And that is, so it is proportional. And here I can tell because it is a straight line and goes through 0, 0. In 0 minutes, she makes 0 crafts. So I can also tell that it's proportional that way. Either of the two methods work. So yes, it is a proportional relationship. And the last question is, what is her unit rate of crafts per hour? Notice it asks for crafts per hour, and I have been dealing over here with minutes. So if I want to find her rate of crafts per hour, I would have to go out to 60 minutes, which would give me 3 crafts if my graph was drawn really well. or I could have continued this. Whoops. It's almost time for lunch to get here. 5 crafts, 2.5, 6 crafts. I'm sorry, 60 minutes, 3 crafts. So if you look at that, it all kind of goes together. So it looks like her rate of crafts per hour is 3 crafts per hour. All right. So that's just kind of how it all fits nicely together. All right, let's do another one. Let's do one together. Open up your notebook. And I'm going to give you the graph in this one. And we'll try making the verbal and the table together. So just let's change the situation a little bit. So we'll do verbal and we'll do table together. All right, so pause here, write down this graph, and then we will go from there to try to make the best of this after that. All right, tables are pretty easy to make from graphs. They've even kind of like neatly put some points on there that we can go ahead and put. So it looks like my X variable, my independent, is time, which is in seconds. And my dependent variable is heartbeats. And they've given us a few to look at. 4 seconds, 6 heartbeats, 6 seconds, 9 heartbeats, 10 seconds, 15 heartbeats, 12 seconds, 18 heartbeats. So I can make my table pretty easily. I can tell from the graph already that this is a proportional relationship because it's straight and goes through the origin. So I can already tell without doing all the division. But if you did all the division here, you're going to get 6/4, which is the same as 3/2. And here you're going to get 9/6, which is the same thing as 3/2. Here you're going to get 15/10, which is the same as 3/2, and so on and so forth. So I'm going to keep getting that 3/2. Every time 2 seconds go by, that's the 2. 3 heartbeats happen, that's the 3. So you just find your intervals there. Every time I do 2 here, I do 3 here. That's where this constant of proportionality comes from. It's, it's the ratio in which they're going up. All right, so we know all that. And since I just explained that way, let's make that our verbal. I just kind of said every 2 seconds, 2, 2, 2, 2, your heart beats 3 times. 3. Well, there's more than 3 because I skipped one here. 3. So every 2 seconds, your heart beats 3 times. And if you look at that, you can see the constant of proportionality in there. The 3 and the 2 are in the verbal also. So you can really find your constant of proportionality almost from there because you know it's going up in that equal ratio of 2, 3, 2, 3, 2, 3, 2, 3. Okay. So the last question is, what is the unit rate of heartbeats per minute? Notice I'm not in minutes. My unit rate of heartbeats per second is the constant of proportionality. 1.5, 3/2 beats per second. So what's cool about this, the constant of proportionality and the unit rate are the same, which is a big thing to come out of this, right? You see 1.5 here, 3 beats in 2 seconds equals 1.5 per minute. So we see that 3/2 here, we see that 3/2 here, and we see that 3/2 here. The unit rate and the constant of proportionality are the same thing. They're that 3 and that 2 that this goes up in. So they all are the same thing. And I can also find that on the graph, right? If I go to 1 second, I can see 1.5 beats, and that's my unit rate too. So all this stuff goes together. You can find this constant of proportionality and this unit rate like all over the place. It's here, it's here, it's here, it's here, it's It's just all over the place. And I just want you to know that all this stuff all like really just fits together really nicely. But to finish the question, I'm not asked for heartbeats per second. I'm asked for heartbeats per minute, so I need to change my unit. So if it beats 1.5 times per second, you know, there's 60 seconds in a minute. So this 1.5 would happen 60 times, and that would be 90 beats per minute. That you don't see all over the place because I had to change my unit. Since this wasn't in minutes, we're not going to find it on there. Since this wasn't in minutes, we're not going to find it on there. But sometimes you just have to do that. Okay, so that's just kind of hopefully to tie proportionality, unit rate, constant of proportionality, graphs, tables, verbals, all into one nice, neat package with a bow. They all really fit together well. All the information's in all three. It's different ways to show the same thing. And so I hope it's something you're getting really comfortable with and starting to see how it all goes together. That is it for today. I will see you tomorrow.